Hi everyone and welcome back to the multiverse of 100 plus data science project series. In this video, you will learn how to create an any movie recommender system using LangChain and large language model. So this is the demo application, how it look like. It will taking one input box and when I click in the submit button, it will giving me some kind of recommendations based on my input. So I'm going to give it here one input. I am looking for a sci-fi anime with space battle. Any recommendations? Now let's click on submit button. And in the sections, you can see that it will give me some kind of recommendations. So based on your interest in sci-fi anime with space battle, I would like to recommend the following three anime. This is the anime number one, anime number two, anime number three. That's the movie, I mean any movie. Now in this tutorial, we're going to creating here this full applications from a scratch using Python, LangChain, and Llama. So without wasting any time, har har Mahadev Balka start karte tutorial. So in order to creating here this any movie recommender system, we're going to using here the LangChain. So I need to installing here some of the important libraries just like LangChain, LangChain Community, LangChain Grok, and the ChromaDB as well as the Gradio. So let's use here the Shift Enter, or also you can using here this Run button. So LangChain is nothing but one library, or you can say framework, and using this one you can creating here some Gen AI applications throughout the large language model. Then you have the LangChain community as well as the LangChain Grok. Because you're going to be using here the free and open source model from the Grok clouds, so that's why LangChain Grok is helpful. Using this one, we can access the API key from the Grok Cloud workspace. Then you have the ChromaDB is nothing but one vector restored database. You can using here files as well. Then you have the Gradio. Gradio is nothing but one library. Using this one, you can creating here some cool interface without writing any HTML or CSS code. So you can see here requirement already satisfied. It's mean it's already installed in this Google Color workspace. So I am simply going to clear the output. And after that, I'm going to importing here the important library. So first I'm going to importing here pandas as PD. So why pandas as PD? Because we're going to also using here one data sets in the form of CSV. So that's why we're going to using the pandas in order to loading here the CSV file. So that's our CSV file called anim with synopsis.csv, which are containing here some informations about our movies, about the any movies. So this is the data set. He just having the five features column, just like the mail ID, name, score, genre, and the synopsis. So mail ID is nothing but some kind of ID, and name is the title of the any movies, and a score is just like the rating of the movie out of 10. And genre, it can be the actions, it can be the adventure, it can be the comedy, it can be the drama, or it can be the sci-fi types of movie, just like the Avengers. And synopsis is nothing but the overview of the actual movie, I mean story of the movie. So when using this one into creating here our recommended system for the any movies. So that's why actually imported the pandas. Now I'm going to import it here the LangChain as well. So let's say from LangChain, let's say LangChain dot chains, I'm going to import it here. Let's say import here the retrieval QA. So using this retrieval QA, you can creating here some kind of retrieval chains, and you can get is the questions and the answers. Then from LangChain, let's say LangChains dot embeddings, we are going to importing here the Hugging Face first. So let's take in the Hugging Face, and I'm going to importing here this Hugging Face embeddings. So using this one, you can creating here the embedding vectors of our textual data. So you can also using here the OpenAI embedding, but in the case of OpenAI, it's paid versions you have to use. You need to also give it the API keys. That's why it's better you can using the free and open source versions. That's mean Hugging Face. You can also using the OpenAI if you are rich enough. So then I'm going to import here LangChain dot document loader. So document loader, I'm going to importing here this text loader, because the data set is containing in the form of textual data. So that's why we're going to using here this text loader. Then I'm going to importing here the character text splitter, because we are going to creating here a rack system. In the case of rack system, you need to split the data in kind of chunks so that you can pass it to the large language model. So let's say from LangChain dot text splitter, I'm going to importing here the character text splitter. Then after that, I'm going to importing here the database, I mean back to restore database. Let's say LangChain dot back to restore database. I'm going to import it here the chroma. And then from LangChain dot document, let's say document loader, dot csv loader. I'm going to import it here, the csv loader. So let's say import the csv loader. So using these pandas, we can as well as load the csv file, and using this csv loader, you can also load the csv files. Now I'm simply going to shift enter. So it will actually load it, you can see. So we can close it right now. And after that, what I can do is simply going to first loading our data set from our directory. So what I can do, I'm going to using here, let's say, I'm going to copy the CSV file path. So let's say copy path. Then I'm going to using here pd dot read underscore CSV. Let's say pd dot read underscore CSV. And inside that, I'm going to give it here the path of these data sets. So this is nothing but a data set. Let's call a name, and then we can simply going to see the head of the name. Let's say name.head. So here you go. So you can see that our data sets is just having the 5 columns: mail id, name, scores, uh, and the genres and the synapses. So we can also dropping some kind of nan value if it have, because in the textual data it maybe have the some nan value. So you can dropping these from the data set. So let's say name dot drop na. So let's say drop na into dropping here the duplicate value or the nan value from here. This is called the data preprocessing part. And after that, what I can do is simply going to combining here the name, genre, and the synopsis in a one data frame, so that you can pass it to our large language model. But you are not actually imported the large language model library yet. So it also imported here this LangChain grok, so that you can also access the llama model. I mean, yes, we're going to using the llama. So let's say from LangChain underscore grok, we're going to importing here the chat grok. Let's say chat grok. So these ones. So now what I can do is simply going to using this one. So shift enter, shift enter, and shift enter. Now you're going to combining here this name, genre, as well as the synapses, so that we can getting here some combined data sets, and we can pass it to our large language model, and our large language model can taking some pattern, and based on that it will give me some recommendations. So now let's creating here a column name called combined data frame. Say combined df, and then you can simply go into using here anim dot apply, and you can using here the lambda keyword in order to accessing here all the data. So let's say lambda, and we are taking from that row, and we are giving here one everything in the case of combined df. So we are going to combine them in the case of titles, the overview, and the genres, as well as the synapses. So what I can do is just taking one everything, and inside this everything we're taking the title, because it's just having the name, so you just make it as the titles in the name case. And then you're going to using here the row, because you're going to using here the lambda. So from the lambda you can directly access all of the value from our data frame. Now in the case of row, we're taking here the name. So let's say name, and after that we're simply going to take in the overview is nothing but the synopsis of the data. I mean, synopsis of the columns is nothing but the overview of our whole enemy story. So we can simply go to take it, let's say overview, and we can take it from the row. So let's say row, and from here we are going to give it here the synopsis, and this is nothing but overview. And after that we can also add it here the genres. So we can add it here, let's say genres, let's say genres. Okay, genres. Make sure your spelling is correct. Yeah, genres. And then you can take it as from the row, and you're going to give it to the genres. Let's say genres. Okay, and then we're going to give it here on axis. Let's say axis is equal to a 1. I mean the column side. So that's our data frame. So we can simply going to running this out, and after that you can also see the data frame. So let's say a name, and you can say that let's say combined df, and you can take in the first one. Let's see first ones. So you can see it just having a title is cowboy bebop, and you can see the overview, as well as in the last it having the genres. You can see genres is actions, adventure, comedy, drama, sci-fi, or space. Now if I asking any questions to our large language model, it can easily understand these things. Now it's better we can also save it inside and data frame too. So what I can do, you can using let's say a name, and inside that you can give it here one name. Let's say combined df, I mean combined df, and then we're going to give it here to csv. Okay, in the from of to csv we can update it here this data frame. So let's say animated, let's say anim, let's say anim updated, let's say updated dot csv. and then you can give it to our index. Let's say index should be false. We don't need the index. We can shift enter. Now our data frame is in available on here. Now we can simply going to access it. So what I can do, you can simply going to use the pandas here to read this out. Let's say read CSV, and inside this one, we're going to give it to the path of that. Now, if I paste it here and if I see this path, I mean, if I see this data frame, it look like that. It just having the title, the overview, as well as the genres in one single combined df. It don't have any index. Now you can simply go into use here the data loader, because you're also using here this CSV data loader, and you can also uh, 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 put it inside the vectors to database using LangChains. So you can give it here one heading as well. So let's say data loader. Let's say data loader and vector store. Let's say vector store using LangChain. It should be the LangChain like that. So you can just give it here one text, because it has the text as well. It's not like the Jupyter notebook. So you can cut it and you can simply going to paste it to here, or you can bold it, the LangChains, or you can also bold it these ones. Okay, whole thing you can bold it. Okay, so data loader and vector stores using LangChain like that. Now we're simply going to load it using this CSV loader. So let's say CSV loader, and inside that you can give it here the file path. Let's say file path, this ones, and you're going to give it to the path that you copied. Not this one, you're going to copy this one, copy path, paste it. So that's our loader. So let's say loader, and we are going to load it. Let's say loader.load, and after that you're going to making the text into some kind of chunk so that you can pass it to the large language model. So let's say chunk size, let's say 1000 of the chunk sizes, and chunk overlap. If you don't know what is the rack, what is the retrieval augmented generations, just you can watch my previous video where I already building so many projects about the rack systems. So you can also watch the video. Otherwise you can go on the Google and search for that what is a rack actually. So this is the text splitter, and also what are the process to creating here the one rack systems for the custom data set, or for custom PDFs, or for the custom text. So that's what text splitter. Now you're going to using here this one. Let's say text splitter dot split, split the documents, and you're going to passing here the data. So our data is nothing but this one. So we're going to store it inside a variable called data. And this is nothing but my text. So let's say text. Now it is split it into some kind of chunk. Now we can simply going to pass it to our Hugging Face embedding. So let's say our Hugging Face embedding, and inside that you can you can mentioning here the model that you're going to using it here, but you're not going to using it here because you're not using any API key for the Hugging Face. So if you are using an API key in the secret of here, so you can easily mention the model on here. So it's just using the default model in the case of Hugging Face. Let's say embeddings. So then when you talk initialize here our large language models. So let's say LLM is equal to chat grok. So chat grok. Now inside that you need to give it here the API key, as well as you need to give it here your model, and as well as you need to give it here the temperature. Let's say model. So let's say model, and then you also give it here a parameter called temperature. Let's make it as 0. Now we need to go inside our Grok Cloud workspace and to also checking for the API key. So let's go on here. So that's our Grok Cloud workspace. You can type in equations and you can submit it. So we just need the API key. So just go on the API key and create one API key. So let's say project like that. You can give it here any kind of name, and it will verifying that, and when after clicking here submit button, it will give me one API key so you can access it. So you can copy this out and you can simply go to paste it to our Google Colab. So you can also go to the documentation sections, and then you can see that what kind of model or which kind of model are available on here. You can see the in the productions model, you can see the Gamma 2 Llama 3.3 17 billion versatile model, as well as it having the DeepSeek R1 model as well. So you can using any of the model from here. So what I can do, I'm going to go on the Google Colab and I am going to pass it here the API key that I copied. And the model I'm going to using the Llama model. You can also using here the DeepSeek R1. So I'm going to using here this model, Llama 3.317 billion versatile. Or you can also using here this DeepSeek Aaron Distill Quant 332 billions. This is an distillation models, so you can use it here. So I'm going to using this one actual on this llama model versatile models. So that's our large language model. So you can using here the OpenAI models. You can also using the DeepSeek Iron model from the DeepSeek documentations. So now let's say docs. So that's our actually large language model. Now it also store it inside one vector studio database. Let's say chroma. So let's say chroma dot from documents. Let's say from documents, and inside that you're going to passing the text and the embedding. So let's say embedding that you actually converted. Let's say embeddings. Okay. So this is nothing but my docs search. Okay. Let's say docs search. Now let's shift enter and just wait for a few seconds, because it will taking few seconds or a few more time in order to loading, in order to splitting, or in order to convert them into the hugging face, I mean embeddings. And also it will loading here this large language model and store it inside the Chroma DB. I hope so we may got some kind of error, because we are not initialized here the Chroma DB yet. So you need also installing these ones. So yep, you installing it Chroma DB. Okay, no error, I hope so. So you don't get any error, I hope so, because I forgot it. Okay. Yep, now it's loaded. Now what I can do is simply going to querying the vector db from the movie recommendations. See, we are not actually using the llama yet. We're just using here the retrieval QA. Let's just have a look that without using the llama model, or without using the large language model, how can you access and how can you retrieve the data from the vector stream database. So you can give it here and title, let's say querying. Okay, querying vector db store for movie recommendation. Let's say recommendations. That's when you are not using here any kind of large language model yet. So you can take on text and you can use it here the bold. Okay, bold. So you can delete it. Now let's try to see this one. How can I do that? So we need to give it here on query, and let's say I am looking for an animated sci-fi movie. Let's say sci-fi movie. Okay, I don't know spelling is correct or not. So let's see. Sci-fi. Okay, it should be fi, not the e. So sci-fi movie, and let's say what, let's say could be, what could you suggest me? Okay, let's say suggest to me. That's my questions. Okay, or you can also give it here romantic movie or action movie, whatever else. Now we're going to search it from the retrieval queue, I mean docs. So let's say docs search dot similarity search. So let's say similarity search. I'm going to passing here the query, and the k is equal to 1. And after that, let us store it inside a variable called docs. So it not here, it should be here. Here, let's say docs. And now let's say, okay, syntax error, it should be the 1. So let's say docs, and we can see these ones. Now you can see here it will recommend me this movie as soon as the animations. This is the movie actually recommended here based on that. See, we are not using here any large language model yet. We're just using the backtrace database. Now let's using here this retrieval QA, I mean retrieval question and answers, and let's see the answer, how it actually work. Now in this case, we're going to using here the large language models. So let's say using QA retrieval for movie recommendations. We actually exploring all of that possible technique. Okay, so that's why it's taking time, obviously taking time. So bold it, that's it. And now we're simply going to using the retrieval QA. That's a retrieval QA, and inside that you can give it to the large language model now, and then you can give it to the chain type. Let's say chain, okay, retrieval QA dot from chain type. So let's say from chain type, and here we can give it here, let's say chain underscore type, and you can give it chain type as a stuff. And you're going to using here the retriever, let's say retriever, and you can give it here doxers dot as retriever, let's say retriever as retriever. And then you can give it here the return source document. So let's say source documents, and you can make it as a true. So that's our retrieval QA with the large language model, I mean llama. So that's our QA. And now we can using this one same thing on here. So let's try to copy this out, this query. And it's better you can give it here in any other query as well. So let's give it here one query. So I'm going to pass it to here. I already copied. So can you recommend a romance anime with a unique storylines? And now you're going to using here this QA. So what I can do, let's say QA, and inside that you're going to give it to the query. Let's say query, and then you're going to give it to the query, and that's my result. So let's say result. Let's say result, and now from the result you're going to taking the result. So let's say result, and from here you're going to taking the results. Okay, it should be the result. Okay, so okay, it should be the result, but we're just having one of these. Okay, so based on provided information, I would recommend here Laplace, a romance anime with a unique storytelling line. The concept of people being born with a cat ears and tails disappear after her first. Okay, so you can see that it will also recommend me this kind of movie outline for the keyword retrieval as well. Now you can also using here the source documents. You can getting here the document. I mean, which document that actually use it in order to retrieval here these questions. So what I can do, you can using here, let's say results, and you can give it to, let's say source documents. Okay, so you can take in the first one. So let's see those one. So you can see here to take in the document from this anim update.csv, and row is nothing but the 125. That's the row actually taken. It's called Kimi ga Nozomu Aliens is the title, and this is the overview as well. So this is how you can see here using this retrieval QA. How can you also creating here a movie recommendation system? So you see that two types of recommendation system. One is for using the backdoor database. Another one is nothing but for using this retrieval QA. Now you're going to see that how can using the prompt engineering here. So let's say prompt engineering. So let's say prompt engineering. So using prompt engineering, you can also creating here the movie recommender system that is pepper on that, I mean the hot topic right now. So what I can do first, I am going to importing here from the LangChain, let's say from LangChain dot prompts, and I'm going to importing here the prompt template. Let's say importing here the prompt templates, prompt templates. So then we need to also initialize here on template for that. So I'm going to copy and pasting here on template. So I'm going to pass it to here. That's our template. So you are a movie recommender system that helps the users to find a name that match their preferences. Use the following pitch of context to answer the questions at the end. For each question, suggest three name with a short description of the plot and the reason why user might like it. If you don't know the answer, just say I don't know. Don't try to make up an answers. So the context, we pass it to here and the questions like that. Now we are going to pass it to our prompt templates. So let's say prompt template. That's the prompt template, and inside that you're going to give it here the template. So let's say template. Let's say template is nothing but the template itself. Then in the case of input variable, we have the two input variables. One is nothing but the context. Another one is nothing but the question. Let's say context, and then you have the question. Let's say questions, and that's our template. So we can store it inside the variable called prompt. So let's say prompt, and then we can simply go into creating here one chain type kwargs. So let's say chain type KWARGS, and you can give it here as a prompt. So let's say prompt, and that's our prompt, so that you can pass it to the Retrieval QA. Now in here, we can copy this out. So with having one valid prompt templates, so we can paste it to here. That's the QA. And in the case of chain type, it's obviously stop. And retriever is always the doxers as retrievers. And return document is true. And in the case of chain type KWARG, we're going to using here this KWARG. That's the chain type KWARG. So KWARG is nothing but my prompt tablet itself. Now I'm going to give it here another questions. So what I can do, I am simply first copying this out. So I'm going to copy this out, and I am simply going to paste it to here. So in this case, I'm going to copy it here another one. So that's some kind of prompt. So I want to watch an anime with a strong female lead. Any suggestions, or give a list of comedy anime that is lightheaded and fun. You can copy this out. So we can simply going to paste it here. Actually, I uh, taking this kind of line from the chat GPT for testing purposes. So that's why this kind of text pipeline is actually coming on here. Okay. So let's try to printing it here. Let's try to print here result of the result. Okay, let's say result. Oh, not like that. Result. So now let's see the result for the based on query. You can see happy lesson TB, and it's called Janshikens and Megami Sama TB. Okay, it's nothing but the serial of the TB. I have some kind of fun on that. Okay, so you can also see the sources as well. Now let's try to give it here one second template. It providing here some additional users info to the context. So let's give it the second template. It's nothing but just kind of second template. It's just having some extra information about the users. Okay, so we can copy, we can cut, and we can give it to here. Let's say second template, and I'm going to paste it to the code for that. So let's try to paste it to the code. So you already imported here the langchain.prompt import the prompt template. It's not needed at all, but you just add it here. So we're having three things. One is called template prefix and user informations info, and the template suffix. So you are a movie recommender systems that help user to find a name that match their preferences. Same thing. This thing and this template thing is almost same, but in the case of user info, I just give it here some kind of user info. This is what we know about the users, and you can use this information to better tune your research. And we gave it here the age, genders, and in the case of template suffix, we actually give it the questions. And you're using the user info that format, and age is nothing but the 18 right now, so that it not recommend here some kind of bad movies. So that's why I give it the gender as a 18, and gender is nothing but the females. Just give it here. You can give it here the male as well. And we combine this prompt in the case of template prefix, the user informations, and the template suffix as well. So that's the combine the prompt template. So you can see age is nothing but 80 and gender is female. So you can also make it as a male as well. It's up to you. Now in here, we're simply going to using this one, the same thing. So we're going to copy this out. We're going to copy this out, and we're going to pass it to here because our prompt is same thing in here. So we can simply going to say that our template is nothing but this combined prompt. So we can use this one. Template is nothing but this combined prompt, and this one is as well as prompt because the variable name is same, and chain kwrg is also the prompt. And now I can ask in the question from here. So let's try to ask the question from there, and let's see what kind of information we got. So you can see here it gave me four suggestion movie based on the information provided. So I can also ask in here another one. So let's say which anime would you suggest for someone new to anime. So I'm going to copy this out, and I'm simply going to paste it to here. So let's paste it to here, and you can see it will just consider you are new in anime and 18 years old. I suggest Gaukian Allies as a great starting point. It's heartwarming comedy with a mix of school life. See, good thing actually recommend them. Okay, so this is how this anime movie recommend system actually work in the case of LangChain and Llama. Okay, now we're going to see that how can you creating an interface using Gradio library. So for that, you also install the library called Gradio, but we already installed this library Gradio, right? Now I'm simply going to write in the code, and after that I will give you one overview or make you understand that how this code work actually. So now it's time to creating here our interface using the Gradio. You can also using here the Streamlit or the Flux if you're using your local machines. So just imported the Gradio as a years and the same thing. I mean, same kind of library that you're going to use it here. And then we load here the enum data set. We are going to combine them. We're going to save the data set. We're going to making a character text splitter as well as we're going to creating the embeddings and define our large language model. And then we having one templates. We're going to using here the templates one, so that's the template. You're going to using the first one. You can also using the second one, second template as well. So it having the user informations and the template suffix as well. And then you're simply going to creating here one prompt template, QA chains, and then you're going to creating here functions. And these functions taking one query and returning here the results. So you can see here we just also give it here one kind of theme. Okay, so in the theme, we give it a Respire, a Shiki, and the version is nothing but the 1.2.1. Or you can using here any kind of theme from the Gradio theme library. Then you're going to creating here interface using this gr.interface, as well as you can also using here gr.block. And then in the case of functions, you're going to passing here this recommend any functions that you created, and we having one input text box, and you give it here on label, enter your anim preference, and the output case it will recommend here the anims, and title we give it here any movie recommender, and theme we pass it to the theme that you already initialize. You can also using the soft theme, or you can also using the direct theme as well. Then you're going to calling here the main method in order to launching here our interface. So it's so easy to creating here the applications using the Gradio library. You can also using the Streamlit, or you can using the React.js if you are expert in that. Okay, and you're already creating here so many applications using React.js as well. So you can follow this out. So you can see here it is running and one link is appeared. You can see here how it look like. So this sure link expired in 72 hours. So after 72 hours, you can access the link. And until that, you can access this link. It will be live. Okay. So you can see here it is loading the interface, and then you can give it here some kind of questions. So let's zoom it and let's try to taking some questions from here. So let's say uh, let's say suggest me an anime similar to Attack on Titan, this kind of movie. So I'm going to paste it to here and let's click on submit. And then it will recommend me here three movies. I hope so. Yeah, three movie. So based on the popularity of Attack on Titan, I'd like to suggest the following anime that share the similar themes and elements. One is called Neon Genesis Evangelions. The anime like Attack on Titan features giant human animation like that, and Genusaka the animations, then Gun Parade merch, okay, like that. I don't know because I'm not watching the anime too much. I'm just watching the Motu Patlu in the when I was in just 10 or 15, 10 or 12 years old, right? Watching the Motu Patlu, Tom and Jellies, not Jelly, actually Tom and Jerry, then Augie and the cockroaches like that. Okay, so this is how this any movie recommender system actually work. You can create it using LangChains or large language models. So thank you and bye bye. Namaste.